October 15, 1988, Northrop Corporation's Advanced Systems Division, Pico Rivera, California. The radar cross-section measurement had been run 17 times across 14 separate frequency bands. The technicians rechecked their instruments. The engineers recalculated their equations. The security officers verified the chamber seals. Every iteration produced the same impossible result. At certain angles and frequencies, the B-2 Spirit strategic bomber registered a radar signature smaller than a large bird. The aircraft itself sat in the anechoic test chamber like a mathematical theorem made physical. Flying wing configuration spanning 172 feet with no vertical surfaces, no right angles, no protrusions that could reflect electromagnetic energy back toward a transmitter. Composite materials absorbing rather than bouncing radar waves. Engine inlets buried deep in the wing structure. Exhaust ports flattened and cooled before release. Every fastener, every seam, every access panel designed to minimize detectability. What the engineers at Northrop had created was not merely an advance in stealth technology. It was a categorical rupture in the mathematics of air defense. Soviet radar systems that could track conventional bombers at 200 miles would detect the B-2 at perhaps 20 miles, maybe less. By the time detection occurred, the bomber would already be over its target. The program manager, John Cashin, understood immediately what the test results meant. The B-2 would revolutionize strategic warfare. It would also become impossible to replace. The development timeline told a story of obsessive refinement that bordered on madness. The Advanced Technology Bomber program had begun in 1979 with requirements that seemed designed to be impossible. Penetrate Soviet air defenses at high altitude. Deliver nuclear weapons with precision. Remain undetectable until weapon release. Operate from bases anywhere in the world. Do this while carrying 40,000 pounds of ordnance across 6,000 nautical miles without refueling. Conventional aircraft design offered no pathway to these specifications. The Air Force and Northrop engineers had spent 8 years creating something that barely resembled an aircraft at all. The flying wing configuration required computer-assisted flight controls because the design was aerodynamically unstable without constant electronic correction. Human pilots could not fly it manually for more than a few seconds. The materials posed challenges that made conventional aircraft fabrication look primitive. The skin consisted of composite materials mixed with radar-absorbing compounds. Each panel required precise alignment. Temperature variations during assembly could create microscopic gaps that would light up Soviet radar screens like emergency flares. The manufacturing tolerances were measured in thousandths of an inch across structures spanning nearly 200 feet. The cost implications were already apparent before the first operational aircraft rolled out. Each B-2 required 9.2 million parts. Assembly took approximately 12,000 hours of labor per aircraft. The specialized facilities at Air Force Plant 42 in Palmdale, California, were custom-built for B-2 production and could not be repurposed for other aircraft. The initial unit cost projection of $200 million per aircraft was already obsolete by 1988. The actual figure would approach $1.2 billion when development costs were included. Senior Air Force planners reviewing these numbers in classified briefings understood the mathematics of replacement immediately. If a B-2 was lost in combat, replacing it would require 18 to 24 months of manufacturing time, assuming all materials and components were immediately available. The production line could not be accelerated. The specialized workforce could not be expanded quickly. Each aircraft represented an irreplaceable strategic asset the moment it became operational. What none of them fully grasped yet was how this irreplaceability would fundamentally alter American military doctrine. The Soviet Union's air defense network in 1988 represented the most comprehensive integrated system ever constructed. Over 10,000 surface-to-air missile launchers deployed across Soviet territory, 2,300 interceptor aircraft on constant alert, ground-based radar stations operating in overlapping coverage zones, airborne early warning aircraft extending detection ranges hundreds of miles beyond Soviet borders. The system was designed on the assumption that any attacking bomber force would be detected, tracked, and engaged long before reaching strategic targets. Soviet air defense planning officers calculated that even if the United States launched its entire B-52 and B-1B bomber fleet simultaneously, fewer than 30% would penetrate to their targets. Acceptable losses for a strategic nuclear strike, catastrophic losses for any conventional operation. The mathematics ensured that American bombers remained primarily a nuclear deterrent force rather than a practical conventional weapon. The B-2 invalidated these calculations entirely. Colonel Richard Couch, assigned to Strategic Air Command's War Planning Division in 1989, received his first detailed B-2 briefing in January of that year. The classified presentation included radar cross-section data, penetration probability calculations, and mission planning scenarios. The numbers produced a revelation that Couch later described as professionally disturbing. A single B-2 equipped with precision-guided munitions could accomplish bombing missions that would require dozens of conventional aircraft and accept heavy losses. The stealth bomber could approach targets from any direction without early warning. It could loiter over target areas for hours waiting for optimal strike conditions. It could penetrate air defense networks that would annihilate conventional bombers before they reached hostile airspace. But these capabilities created a planning paradox that became apparent immediately. The B-2 was so effective at penetrating defenses that it became the only viable option for certain high-value targets. Simultaneously, it was so expensive and difficult to replace that losing even one represented an unacceptable strategic loss. The first B-2 Spirit, designated AV-1, completed its maiden flight on July 17, 1989. Test pilot Bruce Hines spent 2 hours evaluating basic flight characteristics over the Mojave Desert. The aircraft performed exactly as computer models predicted. Flight controls responded precisely. Stability augmentation systems functioned flawlessly. The flying wing configuration that looked so alien on the ground flew with eerie smoothness at altitude. What Hines and the test team discovered over subsequent months of flight testing was that the B-2 represented not just a stealth platform, but a fundamentally different approach to strategic bombing. The aircraft's range of 6,000 nautical miles without refueling meant it could strike targets anywhere on Earth from bases in the continental United States with a single aerial refueling. The precision navigation systems allowed autonomous operation with minimal crew intervention. The defensive systems suite could detect, identify, and categorize threats automatically, recommending optimal evasion routes without pilot input. The bomber required a crew of only 2 pilots, no navigator, no bombardier, no defensive systems operator. The onboard computers handled functions that required 6 to 7 crew members in previous strategic bombers. This crew reduction seemed like an advantage until planners calculated training timelines. Training a qualified B-2 pilot required approximately 18 months from initial selection to operational certification. The flight characteristics were so different from conventional aircraft that experienced bomber pilots had to essentially relearn flying. The mission systems were so complex that pilots needed extensive training in threat detection, electronic warfare, and autonomous navigation. The stealth requirements meant pilots had to understand radar physics, electromagnetic signatures, and defensive tactics at an engineering level. The Air Force calculated that maintaining operational proficiency required each pilot to fly approximately 120 hours annually, in the B-2 specifically. Simulator training could supplement, but not replace, actual flight time. With only 20 operational aircraft planned by 1990, the pilot pool would remain perpetually small, specialized, and irreplaceable. Captain John Donovan, selected for B-2 training in 1990, described the aircraft as simultaneously the most capable and most constraining platform he had ever flown. In a letter to a former squadron commander, Donovan wrote that the B-2 could accomplish missions impossible for any other aircraft, but every mission had to be planned with the understanding that losing the aircraft would be strategically catastrophic. The psychological pressure of flying an irreplaceable asset exceeded anything experienced in conventional bombers. By late 1990, Strategic Air Command possessed 3 operational B-2 aircraft. Production continued at Palmdale at a rate of approximately 1 aircraft every 8 months. The initial procurement plan called for 132 aircraft. This number was derived from war planning requirements, assuming conventional warfare against Soviet forces. The Cold War's sudden end in 1989 immediately called this requirement into question. Defense analysts in the Office of the Secretary of Defense began reviewing the B-2 program in light of the collapsing Soviet Union. Their classified assessments revealed strategic assumptions that had become obsolete almost immediately. The massive Soviet air defense network that justified the B-2's development was fragmenting as the USSR dissolved. The nuclear targeting requirements that demanded 132 aircraft were being revised downward as strategic arms reduction treaties took effect. More critically, the per-unit cost projections were escalating beyond any reasonable procurement budget, with development costs already exceeding $23 billion by 1990. Distributing these costs across 132 aircraft yielded a unit price of approximately $550 million, reducing the procurement to 75 aircraft, pushed unit costs to $750 million. Further reductions created a financial death spiral where each cut increased per unit costs, justifying further cuts. By 1992, the procurement plan had been slashed to 21 aircraft, including test models. The unit cost, including development, exceeded $2 billion per aircraft when measured in 1997 dollars. Each B-2 now represented not just a strategic bomber, but a portion of the entire defense budget comparable to a nuclear aircraft carrier. The Air Force struggled to articulate how these extraordinarily expensive and rare aircraft would actually be employed. War planning scenarios that assumed dozens of B-2s conducting simultaneous strikes no longer applied. Mission planning that accepted potential losses became unthinkable. The aircraft designed to be risked in nuclear war became too valuable to risk in any war. The first genuine test of B-2 operational doctrine came in August 1990 when Iraq invaded Kuwait. The crisis offered an ideal scenario for demonstrating stealth bomber capabilities. Iraqi air defenses were extensive, Soviet-equipped, and well-trained. Baghdad was one of the most heavily defended cities in the world, with overlapping radar coverage, integrated command and control, and dense anti-aircraft artillery. Strategic Air Command planners immediately began developing B-2 strike packages targeting Iraqi command facilities, communications nodes, and strategic weapons sites. The missions were technically feasible. A single B-2 could penetrate Iraqi airspace undetected, strike multiple high-value targets with precision weapons, and egress without Iraqi forces ever knowing it had been present. The missions were never approved. Colonel Hal Hornberg, involved in the planning effort, later explained that senior Air Force leadership could not accept the risk of losing a B-2 in the opening days of the Gulf War. The aircraft was too new, too rare, and too politically sensitive. If a B-2 was shot down or suffered mechanical failure over Iraq, the entire stealth program would face intense scrutiny. The technological advantage that justified $40 billion in development costs would be compromised. The psychological impact on American military confidence would be severe. Instead, the Air Force deployed F-117 Nighthawk stealth fighters. These aircraft were older, smaller, less capable, and far more numerous. Losing an F-117 would be operationally unfortunate, but strategically acceptable. Losing a B-2 would be catastrophic. The Gulf War's opening night on January 17, 1991, demonstrated exactly why the B-2 had been withheld. F-117 struck targets in downtown Baghdad with precision, but several Iraqi air defense systems successfully tracked the stealth fighters at close range. One F-117 took damage from anti-aircraft fire. The mission succeeded, but they revealed that stealth technology was not invulnerable, just highly resistant to detection. If B-2s had flown those missions, even successful strikes would have exposed the aircraft to Iraqi defenses. Gun camera footage, radar recordings, and pilot observations would have provided intelligence on B-2 radar signatures, flight characteristics, and operational tactics. This intelligence would have spread to every potential adversary within months. The strategic value of the B-2 fleet depended partly on adversaries not knowing its exact capabilities. The decision to withhold the B-2 from combat operations established a pattern that would persist for years. The bomber was reserved for contingencies so severe that risking irreplaceable assets became acceptable. This category proved extraordinarily narrow. Throughout the 1990s, Air Force war planners developed detailed B-2 employment scenarios for conflicts ranging from renewed war in Korea to Chinese aggression against Taiwan to Russian revanchism in Eastern Europe. Each scenario concluded that B-2s would be decisive if employed. Each scenario also concluded that conventional aircraft and cruise missiles could accomplish the same missions with higher risk but acceptable costs. The B-2 remained in training status, flying regular missions to maintain crew proficiency and demonstrate readiness, but never approaching actual combat. The aircraft designed to operate in the most dangerous threat environments flew primarily over Nevada test ranges and the continental United States. By 1995, the entire operational B-2 fleet consisted of 16 aircraft assigned to the 509th Bomb Wing at Whiteman Air Force Base, Missouri. 4 additional aircraft remained in test status. One had been destroyed in a 1989 ground accident. The production line at Palmdale had closed permanently in 1997 with the delivery of the final aircraft. The closure of the production line marked the point where B-2 irreplaceability became absolute and permanent. Aircraft losses could no longer be replaced at any cost. The specialized workforce had dispersed. The manufacturing facilities were being repurposed. The material suppliers had moved to other contracts. Theoretical studies suggested that restarting B-2 production would require approximately $10 billion in startup costs and 3 to 4 years of preparation before the first new aircraft could be delivered. Senior Air Force officers, including General John Jumper, who would later become Chief of Staff, understood that the B-2 fleet represented a fixed and dwindling resource. Normal attrition from accidents and mechanical failures would gradually reduce the fleet size. Each loss was permanent. Within 20 to 30 years, the B-2 fleet would cease to exist through simple wear and aging. This recognition led to a doctrine shift that few outsiders fully appreciated. The B-2 was no longer planned as a weapon to be employed in war. It was a deterrent whose value lay in the threat of its potential use. Adversaries, knowing that B-2s existed and could strike without warning, had strategic value, even if the bombers never actually flew combat missions. The problem with deterrence based on non-employment was that it required occasional demonstrations to remain credible. In March 1999, NATO began air operations against Serbia in response to ethnic cleansing in Kosovo. The conflict offered another test case for B-2 operational employment. Serbian air defenses were obsolete Soviet systems, but relatively dense around high-value targets. Belgrade and other major cities possessed integrated air defense networks that would challenge conventional NATO aircraft. This time, the B-2 flew combat missions. On March 24, 1999, 2 B-2s departed Whiteman Air Force Base on the war's opening night. The mission profile demonstrated both the aircraft's extraordinary capabilities and the extreme precautions surrounding its employment. The bombers flew nonstop missions lasting over 30 hours, including multiple aerial refuelings. They approached Serbian airspace from directions that minimized exposure to air defense systems. They struck targets using satellite-guided munitions that allowed weapon release from altitudes above effective anti-aircraft artillery range. They aggressed immediately after weapon release without loitering. The missions were technically successful. All weapons hit their targets. Serbian air defenses never detected the B-2s. Both aircraft returned to Whiteman without damage, but the operational constraints were revealing. The B-2s flew only at night. They avoided Serbian airspace whenever possible, striking border targets from outside defended areas. They never conducted missions when weather conditions might force flight through clouds where icing could affect stealth coatings. The mission planning required days of preparation, including satellite reconnaissance, signal intelligence collection, and route optimization to minimize even theoretical detection risks. Colonel Anthony Rock, commander of the 509th Operations Group, later acknowledged that B-2 missions in Kosovo were planned with zero acceptable risk tolerance. Conventional aircraft accepted calculated risks based on probability of survival. B-2 planning assumed that any risk, no matter how small, was unacceptable given the strategic value of each aircraft. The psychological pressure on B-2 crews became intense during Kosovo operations. Pilots understood they were flying aircraft worth over $2 billion each. They knew that mechanical failures, navigation errors, or any deviation from planned routes could result in detection and potential loss. They recognized that their aircraft could not be replaced if destroyed. The normal stress of combat was multiplied by awareness that a single mistake could have strategic consequences beyond the immediate mission. Captain John Seeley, a B-2 pilot during Kosovo operations, described the experience as flying with the weight of national strategy on the flight controls. Every decision from takeoff to landing carried implications that exceeded anything in conventional warfare. The aircraft was so capable that it removed many operational risks, but so valuable that it created new categories of strategic risk. Serbian air defense forces, operating primarily Soviet-era SA-3 and SA-6 missile systems, never engaged the B-2s because they never detected them. But post-war analysis revealed several instances where B-2s passed within detection range of mobile radar systems that happened to be operating on frequencies and at angles that could have produced fleeting returns. The margin between invisibility and exposure was narrower than initial planning had assumed. The closest call occurred on the night of March 27th when a B-2 designated Spirit of Missouri flew within 12 miles of an SA-3 site near Valjevo. The Serbian battery was radiating, searching for NATO aircraft. Post-mission analysis using signals intelligence data suggested the radar may have momentarily detected an anomalous return, but failed to recognize it as a target. The B-2's radar cross-section was so small that Serbian operators had no reference to distinguish it from atmospheric clutter, birds, or electronic noise. This near miss was classified and not revealed to most Air Force personnel for years. Had the SA-3 battery launched missiles based on that fleeting detection, the outcome would have been unpredictable. The B-2's defensive systems could have detected the launch and initiated evasive maneuvers. The missiles might have lost tracking lock as the bomber maneuvered, or the missiles might have successfully engaged, potentially destroying an aircraft whose loss would have shocked American military planning. The strategic implications of losing a B-2 in Kosovo would have extended far beyond the immediate tactical situation. The wreckage would have been recovered by Serbian forces or Russian advisors. Stealth coding materials would have been analyzed. Structural design would have been documented. Electronic systems would have been examined. Within months, detailed technical intelligence would have spread to China, Russia, and other potential adversaries, eroding the B-2's primary advantage. The Air Force recognized after Kosovo that even successful B-2 employment created unacceptable risks in anything less than existential conflicts. The decision to deploy the bombers had been partly political, demonstrating American technological superiority and justifying the enormous program costs. But the operational constraints required to protect the aircraft effectively limited its utility to scenarios where other weapons could not succeed. By 2000, Air Force doctrine had evolved to treat the B-2 as a strategic reserve weapon for conflicts involving peer adversaries with advanced air defenses. China's expanding military capabilities and improving air defense networks represented the primary planning scenario. Russia's potential resurgence created a secondary justification. Smaller regional conflicts would be handled by conventional bombers, cruise missiles, and strike fighters, regardless of the tactical advantages B-2s might offer. The September 11, 2001 terrorist attacks created new pressure to demonstrate B-2 combat effectiveness. Afghanistan offered a target environment with minimal air defenses, but extreme geographic challenges. The distance from Diego Garcia in the Indian Ocean to targets in Afghanistan exceeded 2,400 nautical miles. Aircraft carriers in the Arabian Sea could launch strikes, but tanker support was limited. The B-2's range and payload capacity made it ideal for delivering large bomb loads against Taliban and Al-Qaeda positions in remote areas. In October 2001, B-2s flew their first combat missions over Afghanistan. The operational pattern established in Kosovo was refined and extended. Bombers departed Whiteman and flew nonstop missions exceeding 40 hours with multiple aerial refuelings. They struck targets using satellite-guided weapons from high altitude. They avoided even theoretical threats, including shoulder-fired surface-to-air missiles that could reach only 15,000 feet. The missions were effective at delivering ordnance, but operationally cumbersome. Each B-2 mission required extensive planning, multiple tanker aircraft for refueling, satellite communication links for target updates, and contingency recovery bases if weather or mechanical issues prevented return to Whiteman. A single B-2 mission consumed resources equivalent to operating dozens of conventional aircraft. Major Joseph Parham, a B-2 mission commander during Afghanistan operations, later calculated that his aircraft delivered approximately 230,000 pounds of munitions during 6 combat missions. The same tonnage could have been delivered by 30 F-15E Strike Eagle sorties, operating from closer bases. The B-2 missions demonstrated capability, but not efficiency or necessity. Afghan operations revealed another constraint that would become increasingly important. The B-2's stealth coatings required intensive maintenance after every flight. The materials absorbed moisture, developed microfractures from temperature cycling, and degraded under ultraviolet exposure. Ground crews at Whiteman spent hundreds of hours between missions inspecting, repairing, and reapplying coatings. Each aircraft required climate-controlled hangars to prevent coating degradation. The maintenance burden meant that the B-2 fleet could not sustain high operational tempos. Flying 3 or 4 aircraft continuously required pulling maintenance hours from other aircraft. Flying the entire fleet simultaneously was theoretically possible, but would result in extended down periods while maintenance was completed. The bomber designed for nuclear war against the Soviet Union was never intended for sustained conventional operations. The 2003 invasion of Iraq demonstrated these operational limitations definitively. The Air Force deployed B-2s to strike high-value targets during the opening phases of Operation Iraqi Freedom. The bombers flew missions against Iraqi command bunkers, communications facilities, and Republican Guard positions. The missions succeeded tactically, but revealed strategic inflexibility. Iraqi air defenses in 2003 were degraded from 12 years of sanctions and enforcement of no-fly zones. Surface-to-air missiles remained operational around Baghdad and other major cities, but the integrated command network had been largely dismantled. F-117s, F-15Es, and even aging F-16s could strike targets in Baghdad with acceptable risk. The B-2's stealth advantage was unnecessary for most missions. Yet, B-2s flew because their employment had become partly political justification for program costs. Congressional oversight committees questioned why the Air Force maintained the world's most expensive bomber fleet if it was never used. Public demonstrations of capability became necessary to sustain funding for maintenance, upgrades, and eventual replacement systems. The contradiction was obvious to operational commanders. The B-2 was too valuable to risk, except in extreme circumstances, but too expensive to maintain without regular employment justification. The solution was to employ the bombers only in controlled situations where risks could be minimized to near zero, which meant using them primarily where their unique capabilities were not actually necessary. Lieutenant General David Deptula, who oversaw Air Force intelligence during this period, recognized that the B-2 had created a capability employment paradox, unique in military history. The aircraft's effectiveness made it indispensable for certain scenarios. Its irreplaceability made it impossible to risk in those scenarios. The result was a weapon optimized for missions it would never fly, because the stakes of those missions made the risks unacceptable. By 2005, the B-2 fleet had accumulated sufficient operational data for maintenance planners to project the aircraft's service life with some accuracy. The news was problematic. The composite structures were aging differently than aluminum airframes. Microfractures in wing spars could not be repaired using conventional techniques. The stealth coatings degraded steadily regardless of flight hours. The avionics systems used components that were becoming obsolete, with no direct replacements available. The Air Force calculated that without major structural modifications, the B-2 fleet would remain fully operational until approximately 2035. Beyond that date, diminishing numbers of flyable aircraft would create a death spiral where maintenance costs per aircraft became prohibitive. Eventually, possibly by 2045, the last B-2 would be retired regardless of its strategic value. This timeline created urgent pressure to develop a replacement. The Next Generation Bomber program, later redesignated the Long Range Strike Bomber, and eventually the B-21 Raider, emerged from recognition that the B-2's capabilities had to be preserved, even as the aircraft itself aged toward obsolescence. But the replacement program faced the same fundamental challenge that had created the B-2's employment paradox. Any bomber stealthy enough to be strategically valuable would be too complex and expensive to produce in large numbers. Limited numbers would make each aircraft strategically irreplaceable. Strategic irreplaceability would make the bombers too valuable to risk except in existential conflicts. The cycle would repeat. The B-21 program's stated objective included producing sufficient aircraft to sustain operations and accept losses. The planned procurement of at least 100 aircraft acknowledged that replaceability was essential for operational utility, but the projected unit cost of approximately $550 million in 2010 dollars suggested that even this larger fleet would face the same employment constraints that limited the B-2. Meanwhile, the existing B-2 fleet continued flying training missions, conducting occasional combat deployments to demonstrate capability, and primarily existing as a deterrent whose value lay in adversaries knowing it could strike without warning. The actual employment remained constrained by strategic calculation that losing even one aircraft would be unacceptable except in circumstances so dire that the loss became acceptable by comparison. In 2008, one of those circumstances nearly materialized. The B-2 designated Spirit of Kansas, aircraft number 89-0127, crashed on takeoff from Andersen Air Force Base in Guam. The cause was moisture contamination in air data sensors that provided incorrect readings to the flight control computers. The computers commanded a pitch-up maneuver based on false airspeed data. The aircraft stalled at low altitude and impacted the runway. Both pilots ejected successfully. The aircraft was destroyed completely. The loss removed 1/20th of the entire operational B-2 fleet in a single incident that had nothing to do with combat. The strategic impact was immediate and severe. The crash cost $1.4 billion in replacement value for an aircraft that could not be replaced. It reduced the fleet to 19 operational aircraft, including test models. It raised questions about the vulnerability of the entire fleet to common mode failures. Most critically, it demonstrated that the B-2's greatest threat was not enemy air defenses, but the inherent risks of operating complex aircraft under difficult conditions. The investigation revealed that moisture problems with air data systems had been a known issue for years. The sensors were designed to resist moisture, but not to operate reliably when water accumulated in specific configurations. Guam's tropical environment created ideal conditions for this failure. Mode. The aircraft had been deployed to Guam as part of rotational presence operations intended to demonstrate American capability in the Pacific. The deployment itself was questionable from a risk management perspective. Guam offered no operational advantages for B-2 operations that could not be achieved by flying from Whiteman. The bombers were sent to project presence and reassure allies, strategic communications objectives rather than military necessities. The decision to accept the deployment risks for psychological effect rather than operational requirement represented exactly the kind of calculation that made the B-2 so difficult to employ effectively. After the Spirit of Kansas crash, B-2 deployment policies became even more restrictive. Forward operating locations required climate-controlled hangars, specialized support equipment, and extensive pre-deployment inspections. The number of bases capable of supporting B-2 operations worldwide could be counted on one hand. The flexibility that stealth technology promised was constrained by logistical requirements that made the bombers prisoners of their own complexity. Foreign deployments continued, but became increasingly ceremonial. B-2s would deploy to Guam, Diego Garcia, or RAF Fairford in England for brief periods, fly some local training missions, and return to Whiteman. The deployments demonstrated that the aircraft could operate forward if necessary, but the operational pattern revealed deep reluctance to expose them to risks beyond controlled training environments. The Chinese military, observing B-2 operational patterns closely, drew obvious conclusions. People's Liberation Army Air Force publications from this period noted that American stealth bombers were rarely deployed forward, almost never operated outside peacetime conditions, and appeared to be treated as assets too valuable to risk. Chinese air defense planning incorporated the assessment that B-2s would be employed only in the opening hours of a major conflict, suggesting that surviving the initial strikes would largely neutralize their strategic impact. Russian military analysts reached similar conclusions. Soviet-era air defense doctrine had assumed continuous bomber attacks over days or weeks. Modern Russian doctrine assumed that B-2s could conduct devastating initial strikes, but lacked the numbers and sustainability for extended operations. The strategic solution was not to defeat B-2s directly, but to develop enough redundancy in critical systems that initial stealth strikes would be absorbed rather than decisive. Both Chinese and Russian analyses identified the core vulnerability in American stealth bomber strategy. The small fleet size combined with extreme risk aversion created a weapon more valuable as a threat than as an actual capability. Once employed, the mystique would diminish. Losses would be strategically catastrophic. The optimal employment was therefore non-employment, except in circumstances where the alternative was worse than losing irreplaceable assets. By 2010, B-2 operational doctrine had crystallized around this reality. The aircraft would be held in reserve for scenarios involving peer adversaries, with advanced air defenses attacking strategic targets where no other weapon could succeed. This category was extraordinarily narrow and became narrower as cruise missile technology advanced. Tomahawk missiles could strike many targets previously requiring B-2 strikes. Standoff weapons allowed conventional bombers to attack from outside defended airspace. The number of scenarios where the B-2's unique capabilities were absolutely necessary continued to shrink. The 2011 intervention in Libya demonstrated how peripheral the B-2 had become to actual military operations. Libyan air defenses were extensive and relatively modern, including SA-5, SA-6, and SA-8 surface-to-air missile systems. The initial suppression of these defenses would traditionally have been a perfect B-2 mission. Instead, the Air Force employed conventional bombers, cruise missiles, and electronic warfare aircraft. B-2s flew a single mission on the conflict's opening night, more symbolic than operationally necessary, then departed the theater. Colonel Mark Robinson, commander of the 509th Operations Group during Libya operations, later explained that the decision to minimize B-2 employment was driven by operational calculus, that accepting any risk was unjustifiable given the minimal strategic importance of the conflict. Libya's air defenses could be defeated by conventional means within acceptable timeframes. Risking a B-2 would provide marginal tactical advantage at disproportionate strategic cost. The pattern repeated in subsequent operations against ISIS in Syria and in smaller contingencies worldwide. B-2s occasionally appeared in combat zones, flew carefully planned missions with extensive risk mitigation, and departed quickly. Their employment was measured in individual sorties rather than sustained campaigns. They remained what they had always been since achieving operational status: aircraft too valuable to lose, and therefore too constrained to use effectively. The final evolution of B-2 doctrine emerged around 2015 as the aircraft approached 3 decades of operational service. War planners increasingly treated the fleet as a deterrent force whose primary mission was preventing conflicts rather than winning them. the Chinese military's expanding anti-access area denial networks in the Pacific, Russia's modernized air defenses around strategic facilities, and the proliferation of advanced surface-to-air missiles to smaller nations created target environments where conventional aircraft faced prohibitive risks. The B-2's ability to operate in these environments maintained a credible American strike capability that could not be ignored. Chinese planners could not dismiss the possibility of B-2 strikes against command facilities or naval bases. Russian planners had to maintain air defense coverage accounting for potential stealth penetration. The bombers shaped adversary planning and resource allocation without ever flying combat missions against these forces. But this deterrent value depended entirely on adversaries believing that the United States would actually risk employing B-2s in a real conflict. If operational patterns suggested the bombers would be withheld, even in major wars, their deterrent effect would collapse. The Air Force found itself trapped in a credibility paradox, where the bombers had to be risked occasionally to maintain the threat of employment, but could not be risked frequently without depleting an irreplaceable fleet. The solution, never explicitly articulated in doctrine, but evident in operations, was to employ B-2s in carefully staged demonstrations that maximized visibility while minimizing actual risk. Pacific bomber assurance and deterrence missions became regular events where B-2s would fly from Guam or Anderson, conduct visible training operations with allies, approach but not enter defended airspace, and return to base. The missions served diplomatic and psychological purposes rather than operational ones. Chinese and Russian military observers understood exactly what these missions represented. They were theater, carefully choreographed, demonstrations designed to maintain credibility without accepting genuine combat risk. The missions provided useful intelligence on B-2 flight profiles, maintenance requirements, and deployment patterns. They confirmed that the United States remained deeply reluctant to expose these aircraft to actual threats. By 2020, the B-2 Spirit had achieved a unique status in American military history. It remained the most capable strategic bomber ever built, able to penetrate air defenses that would annihilate any other aircraft. It had flown combat missions in 5 different conflicts over 20 years. It had never suffered combat damage or enemy engagement, and it had never been employed in circumstances where its unique capabilities were truly essential, because those circumstances would have made its potential loss unacceptable. The bomber designed to end the Cold War through technological supremacy had become a museum piece operated in combat conditions only when risks approached zero. The weapon that was supposed to make conventional air defenses obsolete had instead made itself too valuable to risk. The revolution in strategic warfare that the B-2 promised had occurred, but in ways its designers never anticipated. The aircraft's very effectiveness had created its own strategic paralysis. The 19 surviving B-2s continue flying from Whiteman Air Force Base. They train regularly, deploy occasionally, and remain in readiness for missions that, careful calculation suggests they will never fly. Somewhere in classified vaults at Strategic Command Headquarters exist war plans that specify B-2 employment against Chinese port facilities, Russian command bunkers, and Iranian nuclear sites. These plans assume circumstances so dire that losing irreplaceable bombers becomes acceptable compared to the alternative. Those circumstances remain theoretical. The bombers remain in reserve, too valuable to lose, too capable to abandon, trapped in their own effectiveness. They represent the ultimate expression of a strategic principle that military planners rarely articulate, but universally recognize. The most powerful weapons are sometimes those held in readiness but never used, not because they would fail, but because success would cost more than could be replaced. The B-2 fleet will gradually age toward retirement over the next 2 decades, maintained at enormous expense, employed in carefully limited circumstances, preserving its capabilities for conflicts that strategic calculation ensures will never require them. It has become the stealth bomber that was too valuable to risk, the weapon too perfect to use, the revolution that consumed itself. The enemy it could not defeat was not Soviet air defenses or Chinese integrated networks, but the mathematics of its own irreplaceability.